Like monopoly money, civil GPS signals have a detailed structure, but no built-in defense against counterfeiting or spoofing. This has serious implications for unmanned aerial systems. At the invitation of the U.S. Department of Homeland Security, the University of Texas Radio Navigation Lab demonstrated this vulnerability in June 2012 by remotely hijacking a small helicopter. Virtually all commercial UAVs depend on civil GPS for navigation. After a remote operator uploads a flight plan with a destination point, signals from the orbiting GPS satellites help the UAV locate itself three-dimensionally. The UAV's autopilot then takes over, moving the UAV toward its destination. Now the malevolent spoofer enters the picture. His spoofing device might be mistaken for a legitimate ground control system, but he has an entirely illegitimate goal in mind. He wishes to hijack the UAV. Inside the UAV's GPS receiver, there is a correlation peak that corresponds to the authentic signals. These three red dots are the tracking points. They try to keep themselves centered on the peak, but the spoofer has caused a false peak to appear. When the spoofer moves the false peak into alignment with the true one, the tracking points get hijacked and the true peak is forced off to one side. The phantom helicopter sliding out the back represents the UAV's false perceived location. Now, as the autopilot commands the UAV, it is the phantom that aligns with the target destination, not the actual UAV. At this point, the spoofer has control of the UAV.
Yeah, I'm ready. I'm holding.
In this preliminary test, performed at Texas Memorial Stadium, we spoofed a hovering UAV into thinking it was moving rapidly upward. The autopilot compensated by sending the UAV hurtling downward. Days later, at White Sands Missile Range, we repeated the test, this time broadcasting spoofing signals over the air from half a mile away. As in the former test, we induced the hovering UAV into thinking it was rising. It responded by plummeting toward the desert floor.